Hi, welcome to Chapter 7 Quiz Review. So, I gave you a packet the other day in class. If you didn't get the packet, then you can you can print it from home, or you can just view it online and write it on paper. That is fine. But I'm going to go through the first page front and back with you as kind of a review. And then the other 2 pages front and back, you're going to try on your own, and I will post the solutions for you to check your work there. So for this first one, in terms of solving quadratics, we did some of this in class the other day, just as a review. If I have an x squared and an x, like on number 1, I know I'm going to have to factor and solve, or I could use the quadratic formula. I think it would be faster this time to factor and solve, especially since there is a 1 in front of the x squared. I can kind of do it the quicker way. So I like to go ahead and do my 2 sets of open parentheses, put it equal to 0. And then I know that the first 2 terms are going to be x, because x times x gives me x squared. And then remember we talked about it's like a little puzzle. It's like my number here is -4, and I'm trying to look for 2 numbers that multiply together to give me -4, but add together to give me the middle number, which is 3. So if I try to find a number that works for that, you might think, oh, 2 times 2 gives me 4, but I can't add or subtract 2 and 2 to get 3. So that's why that one doesn't work. So I got to think of another option. So I think of 4 and 1. And okay, 4 times 1 gives me 4. 4 plus or minus 1 does give me 3. But now I need to think of what sign works. And it ends up being -1. I just always double check it. 4 times -1 gives me -4. 4 plus -1 gives me +3. So that's my number that works here. So over here, I'm going to plug in my +4 and my -1. And now I factored it. If I want to multiply these 2 binomials, I will get the original equation back. That's a way you can double check as well. So now I have factored, but to solve, I'm going to say x plus 4 is equal to 0. I'm setting these 2 parentheses equal to 0 and solving for my 2 terms. And in this case, I end up with x is equal to -4. And I end up with x is equal to +1. I guess I didn't need that positive. And those are my 2 solutions. Again, if I take those numbers and plug them back into the original equation, it will give me a true statement. All right, same type thing over here. I see a 1 in front of the x squared, so I know I can factor the shorter, quicker way. I want to think of the little puzzle off to the side. Then I know that I'm looking for 2 numbers that multiply together to give me -96 and add together to give me -4. I start thinking of some factors of 96. I might think of 4 and 24, but those don't add or subtract together to give me 4. I might think of 6 and 16. And when you're trying to think of factors, you can use your calculator to start dividing numbers in until you find something that works. 6 and 16 don't add or subtract together to give me 4. And then I come up with 8 and 12 that add or subtract together to give me 4. So then I need to think about the signs. And again, the 12 ends up being negative, because 8 times -12 is -96. And 8 plus -12 gives me -4. So those are the magic numbers. So I'm going to fill in here +8, -12. So I factored it. Now I need to solve it. X plus 8 is equal to 0. X minus 12 is equal to 0. And when I solve, I get x equals -8 and x equals +12 as my 2 solutions. All right, get it moved up. So we did some of these in class the other day as well. Remember your perfect squares over here to the right. I'm going to remind you what perfect squares are. So perfect squares are like 2 squared is equal to 4, 3 squared is equal to 9, 4 squared is equal to 16, 5 squared is equal to 25, and of course that keeps going. So I want to try to think of those perfect squares. So I know some people like to use a factor tree. I don't generally do that, but you can if that's helpful to you. The way I generally do it is I think, okay, what perfect square goes evenly into 44? And again, my perfect squares are these circled numbers over here. And you can use your calculator to find one of those that goes in evenly. And in this particular case, it ends up being 4. So I know that 4 times 11 means the same thing as 44. And so now to reduce it down, I can take the square root of 4 and get 2. I cannot take the square root of 11, so it has to stay in 11. Okay, so 2 squared 11 is my simplified radical. If you want to check your answer, you can type square root of 44 in your calculator and look at the decimal. And then you can type in 2 squared 11 in your calculator and look at the decimal, and you should get the same thing for both if you've done it right. So like in this case, if I type in square root of 44, I get 6.63, and then it keeps going. And if I type in 2 squared 11 in my calculator, I get 6.63, and it keeps going. So that just kind of verifies that I did it correctly. On the next one, I'm trying to think of a perfect square that goes into 56, and it's 4. 4 times 14 gives me 56. It means the same thing. So now I can take the square root of 4 and get 2. I can't take the square root of 14. So this is how my answer stays. I always want to check the number under the square root. If there's a perfect square that goes into that one, I would need to do it again. It's like a fraction that's not simplified all the way down. If you have to do it again, when you go to bring the number out front, if there's something already there, you would multiply those two numbers. Okay. All right. Here, if you think of the perfect square that goes into 125, it would be 25. So I know that 25 times 5 gives me 125. I can take the square root of 25 and get 5. I can't take the square root of the other 5, so it has to stay in the square root. And so that's my answer. All right, moving right along. Are the triangles similar? So it says determine whether the triangles are similar. If so, write a similarity statement and name the postulate or theorem you used. If not, explain. So if we look here, then I can kind of see that these triangles overlap right here at angle Q. So if I could see that the corresponding sides are proportional along with that angle in the middle, I could say that the triangles are similar by side angle side similarity. But I need to check those ratios of the sides, corresponding sides, to see if they match up. So if I check QU for the small triangle over QT for the large triangle, then, QU is 3 and QT is 10. Okay, 3 plus 7, which is 10. Now, if I check the other side, I've got QR over QS. So QR is 2 and QS is 8. And that reduces down to 1/4. But 3/10 and 1/4 are not equivalent ratios. So the answer is no. Determine whether the triangle is similar, not similar. It says if not, explain, and I'll say because scale factors are different. Okay, on number 7, I don't know anything about the angles, but I know all 3 sets of sides. So the way I can do that is I can go like smallest to smallest, medium to medium, biggest to biggest, and check those scale factors. So if I start with the smallest, I've got BC over PN. So BC is 12, PN is 8, and I can divide 4 into both of those, so it reduces down to 3/2. If I try the medium lengths, then I can go AC over, let's see, NO. So AC is 30, NO is 20, and that also reduces down to 3/2. I still need to check the last one. So the largest is AB over PO. So AB is 36 and PO is 24. And I can see in that case that 12 divides evenly into both of those. So again, I end up with 3/2. So since all of those are the same scale factor or same ratio, then I would say yes, that they are similar to each other. Okay, and since they're similar, it says write a similarity statement. So remember, the order these letters matters. It doesn't matter how I name the first one. I'll just say ABC, but now it does matter how I name the second one. So if I said ABC, I went across the large side and then across the small side. I need to follow the same pattern over here. So across the large side is OP, and then across the small side is N. Okay, and then now I need to give a reason why they are similar, and in this case, it would be side, side, side similarity. Okay, moving right along, same directions here. In this case, similar to the one that we just did on number 6, they overlap right here. So I need to check the ratios of these sides, and if they're the same ratio, then I could say they're similar by side angle side similarity. I can see this length is 75. I could see this length is 60. So if I check my ratios, I've got HI for the small triangle over HE for the large triangle. And that gives me 50 over 75. And 25 divides evenly in both of those, so I end up with 2/3. If I check on the other side, I've got HG over HF. So that gives me 40 over 60. 20 goes evenly into both of those, so I end up with 2/3 also. So because the two sides have the same scale factor and the angle right in the middle is congruent for each, then I can say, yes, these figures are similar. I can give the similarity statement. Be careful with the order of the letters. I can say IHG is similar to. So in this case, I went for the little triangle, went across the large side and then across the small side. And so I need to follow the same thing for the big triangle, across the large, across the small. So EHF. And then my reason is side angle side similarity. Okay, over here on number 9, if I know two angles and I want to find the third, I can just add those up and subtract from 180. So I end up with angle J is 56. Same thing over here. I can add these two angles up, the 63 and 76, subtract from 180, and I get angle X is 41. And in this particular case, I can say that they are not similar to each other because the corresponding angles are not congruent. So corresponding angles not congruent. Okay, remember for two figures to be similar, one of the reasons would be angle similarity, and there aren't any angles. I guess there's one angle that's congruent for each, but I'd have to have at least two angles congruent for each. So yeah, remember when triangles are similar, corresponding angles are congruent and corresponding sides are proportional. So that's something you always need to double check. Okay, moving right along. On number 10, and then in this case, it says the triangles are similar. Okay, now find the value of X. They're not asking if they're similar, they're telling you they're similar. So in this case, and you can see that these little angles are congruent, and you can see there's right angles there. So use those to help you set up your proportion correctly. So I can say 7 that's between the 90 and the no mark corresponds with the 21 that's between the 90 and the no mark. And come back to the left triangle, 40 that's between the 1 mark and the no mark corresponds with the 4x plus 4 that's between the 1 mark and the no mark. Okay, if I go and cross multiply from there, I've got 7 times 4x plus 4 is equal to 21 times 40, which is 840. If I go ahead and multiply out there, I get 28x plus 28 is equal to 840. And so I end up with 28x is equal to 812. And when I go and divide by 28 on both sides, I get x equals 29. Okay. This, I have a little more room to write. Okay. Now on number 11, what's going on here is I see that these two lines are parallel to each other. So I know these two angles are congruent because since the lines are parallel, corresponding angles are congruent. These two angles must be congruent to each other. And I also know this angle where they overlap has to be congruent for each. Okay, so I basically have a small triangle and a large triangle that I can use to set up a proportion. So just make sure you stay consistent. If I go bottom of the small triangle, x minus 1, over bottom of the big triangle, 2x plus 4, that has to be equal to 6 for the small triangle that's between the 2 mark and the 3 mark. And then for the big triangle between the 2 and the 3 mark is actually this whole length, which is x plus 6. I don't want to just say x. So be careful with that. If you want to redraw the triangles, if that's helpful to you, feel free to do that. If you think that would be helpful. Okay, so now we just need to solve this. So if I multiply x minus 1 times x plus 6, one diagonal, that has to be equal to 6 times 2x plus 4. Okay, if I go ahead and FOIL this left side out, I've got x times x is x squared, x times 6 is 6x, negative 1 times x is negative 1x, and negative 1 times 6 is negative 6. If I distribute on the right, I end up with 12x plus 24. Okay, from there, if I go ahead and combine my like terms here on the left, I've got x squared plus 5x minus 6. Okay, now because I see that x squared and that x, that's my clue that I need to get everything to one side of the equal sign so that I can factor and solve. So I'm going to subtract 12x from both sides, and I'm going to subtract 24 from both sides. So when I do that, I end up with x squared minus 7x minus 30 equals 0. Okay, now that's my clue that I need to factor and solve because there's the 1 in front. I can do it the shorter, quicker way. So I end up with x and x. I'm looking for two numbers that multiply together to give me negative 30 and add or subtract together to give me negative 7. So my magic numbers end up being negative 10 and positive 3. So I've factored now, but to solve, I can set x minus 10 equals 0 and x plus 3 equals 0. And when I solve, I end up with x equals 10 as one answer, and x is equal to negative 3 for the other answer. All right, I do want to double check that both of these are actually answers. If I take the 10 and plug it back into the picture, there's nowhere where I'd get a negative length or a 0 length that wouldn't make sense, so that one's good. If I take the negative 3 and try to plug it back into the picture, then I would end up getting, say, the bottom of the little triangle would be negative 4. Well, that doesn't make sense. The bottom of the big triangle would be negative 6 plus 4, which is negative 2. The right side of the triangle, that x would be -3. I can't have a negative length in the triangle. That just doesn't make sense. So I'm going to cross that answer out. So that means that one is not really a solution because it doesn't make sense for the geometry picture. It's a solution to the algebra, but it doesn't fit the geometry. So that's why I'm crossing that one out. There was one in the notes yesterday that I forgot to cross out that negative number because of that reason. So if you look back at that, you will need to do that. I was going to mention that next class, but you can go ahead and cross that negative out. I think it was on the last page of the 7-3 notes, maybe number 2. So you can look back at that if needed. All right, on number 12, then it says here that Nina was curious about the Eiffel Tower. You know, you can read through this yourself, but basically we just need to draw a picture and then use that picture to set up a proportion. So if I draw a picture of, let's see, here's my Eiffel Tower, and here's the model of the Eiffel Tower. Okay, and it says the model is 1.2 meters. And its shadow was 0.9. Okay, and it says, then she measured the Eiffel Tower's shadow, and it was 240. And what's the height of the Eiffel Tower? So that's my x. Okay, and the reason this works, the reason I can set up a proportion is because of similarity. I know these things are standing up straight, so those are right angles. And then I know that if we're talking about shadows, there's a sun over here somewhere, a red sun, and it's shining down. And, you know, at one specific instance, that sun is in one spot shining down. So that ray is coming down. So the angle here is congruent for each of those triangles. So I know the triangles are similar by angle similarity, and that's what allows me to be able to set up a proportion. So I can say x, the height of the tower, over 1.2, the height of the model, is equal to 240, the shadow of the tower, over 0.9, the shadow of the model. Okay, just stay consistent when you're setting it up. If I cross multiply, I end up with 0.9x is equal to 288. And then when I divide by 0.9 on both sides, I end up with x is equal to 320 meters. Especially for a word problem, always make sure your answer makes sense with what's going on. Okay, just a little bit more here. On number 13, try and move it up just a little bit more. So have plenty of room. Okay, so on this one, for 13, then what I see going on here, there's two triangles, and I need to decide if they're similar first before I start trying to set up a proportion. And I can see there's a right angle in the two triangles, and I can also see they overlap at this angle right here. So that's what helps me know that they are similar by angle similarity. Okay. If it helps you to redraw the triangles, you can certainly do that. You know, if I redraw the big triangle, I've got triangle A, E, C. If I redraw the little triangle, then I've got D, B, C. Okay, E and B are where my right angles are, and where they overlap is the C. Okay, so if I get those labeled, then I can see for the big triangle that EC is of length of x plus 7 if I add those up. Okay, and for the big triangle, I can also see that this length is 3x plus 5. AC is. Okay, for the little triangle, I can see that BC is 5. That's between the 1 mark and the 90. And I can see that DC is x plus 4 in between the 1 mark and the no mark. So just keep in mind, sometimes figures are flipped or turned, so you have to be really careful that you're getting them labeled correctly. Now I can set up a proportion and solve. And it helps when I have these triangles facing the same way to help me set up the proportion. So I can say 3x plus 5 over x plus 4 is equal to x plus 7 over 5. Okay, now when I cross multiply, I've got 5 times 3x plus 5 equals x plus 4 times x plus 7. From there, I got my 15x plus 25 is equal to x squared plus 7x plus 4x plus 28. Okay, from there, I'm kind of running out of room here, but I want to get 0 on one side. So if I subtract 15x from both sides, I subtract 25 from both sides, I combine these two together, then what I should end up with is 0 is equal to x squared, and I end up with minus 4x, and then I end up with plus 3. So minus 4x plus 3. So now if I factor that, I end up with x and x multiplies together, give me x squared. And my two magic numbers are -3 and -1 because they multiply together to give me +3, add together to give me -4. And so if I go and set both of those equal to 0, I get x equals 3 for one solution, and I get x equals 1 for the other solution. Again, I always want to double check to make sure that they actually both give me positive numbers in my picture, and when I plug them in, they both work, so they are both solutions to this problem. Okay, if you look now at number, I believe it's 14. Yes, number 14. Then they didn't give me a picture this time, so I'd recommend drawing a picture. So if I go ahead and draw triangle ABC, and I'll go ahead and draw PQR. Okay, then I want to go and plug in the things that I know. And remember, the similarity statement is telling me what angles are congruent to what, because corresponding angles are congruent when the triangles are similar. So it tells me angle A is 100. It tells me angle Q is 53. Oops, I labeled these. I want to label these so they're kind of oriented the same way. So since I started at the bottom and went A to the top, B, and then C, I'm going to do the same thing over here. P at the bottom, Q at the top, R over here. So I can kind of have them oriented the same way. So they're telling me Q is 53, and they're telling me C is 2x minus 5. Okay, now if I go ahead and fill in some of the missing pieces here, I know that A and P are congruent because they're first letter. So I'm going to stick 100 in here. I know B and Q are congruent because middle letter. And, technically C and R are congruent also. So yeah, I could stick 2x minus 5 over here in R's place. But another thing that will help me is to figure out what R is. If I know 153, I get 153. If I go and subtract 180 minus 153, then angle R ends up being 27. So if I put that in, that's going to be a little more helpful to me because now I need to solve for X. Is what the directions are asking me to do. And so there's two ways that I can do that. Kind of the quickest way is to realize, oh yeah, well, C and R are congruent to each other. So I can just go 2x minus 5 is equal to 27. And if I solve for that, then I end up with x is equal to 16. Or another true equation you could have written is if you use the triangle on the left, I could have said, oh, well, all those triangles add up to 180, or all those angles add up to 180 since it's a triangle. So you could have gone 2x minus 5 plus 53 plus 100 equals 180. You squeeze it in there. And if you solve for that, you'll get x is equal to 16. So either way works. All right, we're getting close. Last problem. So this one is giving us a hint that substitution may come in handy here. So similar to the last one, the similarity statement is telling me a whole bunch of information in terms of what's similar. And so I know angle A is congruent to angle D. I know B is congruent to E. And I know C and F are congruent. So if I'm going to solve for x and y, I want to set up some true equations to be able to solve. So one true equation I can see is that x plus y is equal to 20. Another true equation I can see is that 12x plus 2y is equal to 100. Another true equation you could write is 12x plus 2y plus x plus y plus 60 equals 180. But we don't really need that third equation, and that one is just going to be more to deal with. So I think these are going to be the two easier ones to use. So if I'm going to solve by substitution, I need to get one of these variables by itself. I think the easiest thing to get by itself is going to be to get x or y by itself over here. It doesn't matter which one. I'll just get x by itself. So I end up with x is equal to 20 minus y. Okay, so if I take this 20 minus y and substitute it in for x's place over here, then I end up with 12 in parentheses 20 minus y plus 2y is equal to 100. From there, if I distribute the 12, then I end up with 240 minus 12y plus 2y is equal to 100. So 240 minus 10y is equal to 100. If I go and subtract 240 from both sides, I end up with negative 140. If I go and divide by negative 10 on both sides, then I end up with 14. So there's my y. If I come back over here and plug 14 in for y's place, then I end up with x is equal to 6. Okay. All right, so thanks for joining in. So the other pages I'm going to have you try on your own, but I will post the solutions. Please try them first, then check your answers, and that will help make sure you are good to go for the quiz.